Hi there. I'm so glad you're here. Maybe it's been a long, noisy day, or maybe you just love falling asleep while thinking about stars, galaxies, and the quiet mysteries of the universe. Tonight, we are embarking on the most magnificent journey of all. We will trace the story of the cosmos from its very first, timid, incomprehensible moment all the way to the end of time itself. But before we begin this long, soothing walk through the ages, I want to hold your attention right at the edge of sleep by showing you something that still baffles scientists to this day. Because our story doesn't even start at the beginning. It starts with a mystery that hints our world may have had a past we never even dreamed of. There is something strange out there. We call it the cold spot. Imagine a map of the ancient light left over from the Big Bang. It is almost perfectly smooth. But in one place, there is a hole, a region of incredible, anomalous cold stretching across hundreds of millions of light years. Like a giant bruise on the body of the cosmos. It shouldn't be there. It is too large, too empty to have been born from the random fluctuations of the early plasma. Some physicists whisper that it is a scar, a bruise from a collision between our newborn universe bubble and another universe. Others say it is a portal to nothingness, a giant void distorting reality itself. No one knows the truth. It is not a scream. It is a silent hint that our cosmos is far stranger than we can ever imagine. This is the first spark of curiosity that will guide us tonight through the darkness and the light. Now get comfortable. Let your breathing slow down. We begin our journey at the point commonly called the beginning of everything. Although, as you will soon discover, the word beginning itself may be deceiving. Chapter 1. When time did not exist. Was there something before the Big Bang? This question sounds childishly simple, but it may actually make no sense at all. We feel that everything must have a cause, that there must be a starting point. But according to general relativity, the Big Bang was not just an explosion of matter into an already existing void. Space itself was born in that moment. Moreover, time itself was born. Asking what came before is like asking what is north of the North Pole. Before that moment, the concept of before did not exist. The clock had not been wound yet. There was only the singularity, a point of infinite density and zero size, where our laws of physics simply break down. But how did this point arise? Some theories suggest our universe is just one of an infinite cycle, that it was not born from nothing, but bounced out of a previous contracting and rebounding world. The cosmos may be breathing, crunch, collapse, a new Big Bang, over and over, with no end. We may be just one link in an infinite chain of rebirths. But let us leave metaphysics and move to what we do know. By the time our world had finally gained time and space, it was only 1/10,000,000,000th of a trillionth of a trillionth of a second old. And then something unimaginable happened. Cosmic inflation. The universe did not just expand, it inflated like a soap bubble, faster than the speed of light. In a vanishingly tiny fraction of a moment, a tiny quantum nugget grew to the size of a grapefruit, and then to the size of a galaxy. And in this frantic rush, the primordial quantum fluctuations were frozen, the very same tremor that would later become stars, galaxies, and us. The entire magnificent structure of reality is simply cosmic scale ripples stretched across the face of primordial chaos. However, it was dark, darker than we can possibly imagine, because photons, the particles of light, could not fly. The cosmos was a scorching soup of plasma, so hot that atoms could not assemble. Electrons and nuclei hurtled around in a continuous fog. This period is called the Dark Ages of the universe. It lasted a long 380,000 years, until finally, the universe cooled to a critical temperature. Electrons found their places in orbits. The fog cleared, and a miracle of clarity occurred. This moment is the oldest snapshot we have. We call it the cosmic microwave background. Imagine, in that instant, the entire cosmos was bathed in a soft, warm, orange glow, resembling the light of a cozy fireplace. Not the black velvet of the night we see now, but a solid wall of light. 13.8 billion years have passed since then. Space has stretched, and that orange light grew tired. It reddened, became infrared, and then turned into radio waves. But it never went away. Even now, right this second, as you close your eyes, you are bathed in this whisper of creation. About 1% of the static on an old analog television when it is not tuned to a channel. That is the voice of the Big Bang. Chapter 2. The Age of the First Giants. After the light broke free, darkness returned again. And for a long time, the only thing filling the cosmos were clouds of slowly condensing hydrogen. But gravity works miracles. In the clumps of gas, growing ever denser and hotter, the first stars ignited. We call them population 3 stars. They were nothing like our sun. They were monsters. Imagine a star hundreds, maybe even 1,000 times more massive than our own. Pure with no traces of metals, they burned with a blinding blue-white fire, millions of times brighter than today's stars. But the price for such brightness is a short life. After just a couple of million years, these titans burned out. Their deaths were magnificent. They collapsed in on themselves in colossal hypernovae, scattering the first heavy elements across the young universe. Oxygen, carbon, iron, they were the seeders. And it is from their ashes that we were later born. While these beacons lit up and faded, gravity dragged matter into giant webs. The universe grew, and with it grew a structure we now call the cosmic web. It is the largest pattern in nature. Invisible filaments of dark matter stretched across billions of light years. And at their intersections, like pearls, galaxies gathered. If you look at a map of this web, it will seem eerily familiar. It looks like a network of neurons in the human brain. A similar pattern, similar connections. The universe is not thinking, of course. But the architecture of the infinitely large and the infinitely small inside your head resonates in a surprisingly beautiful way. Chapter 3. Worlds Gone Mad. Within this emerging structure, objects began to form that still boggle the imagination. Not all planets stayed with their stars. Gravitational slingshots in young star clusters are ruthless. Some planets were hurled away. They are now called rogue planets, and there are billions of them. In our Milky Way alone, there may be more of them than stars. Imagine this eternal flight. Absolute blackness. No sunlight, no change of day or night. Just distant, unblinking points of alien suns and freezing cold. Somewhere out there, in this endless night, oceans may exist under thick shells of ice, warmed only by the heat of a radioactive planetary core, and other planets turned into jewels. If a system is rich in carbon, pressure can transform an entire world into a giant diamond. Astronomers have found a candidate, a planet of crystalline carbon orbiting a pulsar. Imagine a world that sparkles from the inside out. But the most extreme objects are, of course, neutron stars. Imagine, you take the sun, all its unimaginable mass, and crush it into a sphere the size of a small city, about 20 kilometers across. Gravity there is so strong that atoms are flattened. Electrons are smashed into protons, forming a solid neutron mush. A single teaspoon of this material weighs as much as Mount Everest, and some of them spin at insane speeds, hundreds of rotations per second, faster than the blades of a kitchen blender. We call them pulsars. They emit narrow beams of radiation, and when that beam sweeps past the Earth, we hear a click. They are the most accurate clocks in the universe, ticking in the void. And then there are magnetars. Their magnetic field is trillions of times stronger than Earth's. If such a magnetar were as close as the moon, it would simply wipe the data from all credit cards on Earth and rip the iron out of our blood. Luckily, they are very far away. Chapter 4. A Quiet Haven and the Galactic Ballet. Let's move closer to our home. About 4.5 billion years ago, in a quiet arm of the Milky Way, the sun ignited from a collapsing nebula. But it was not alone. It had a twin. We now call it Nemesis. For billions of years, they danced together until a gravitational disturbance tore them apart. Now our lost sibling is lost somewhere among the hundreds of billions of other stars in the galaxy. Our sun is lonely, but it remembers the warmth of those first embraces. Around the young sun, rings of dust began swirling, clumping together into planets, and Earth took its place in the habitable zone. It was hell, lava, meteorites, and then an impact. A planet the size of Mars, Theia, sideswiped us. This crash splashed Earth's mantle into orbit, and it gathered together into the moon. Back then, the moon was dozens of times closer than it is now. It hung there, taking up half the sky, causing monstrous tides. Since then, it has been slowly leaving us. Every year by 3.8 centimeters, about the same speed at which your fingernails grow. It is still running away from the site of our shared catastrophe. Our entire solar system is flying through space, not in a straight line, but in a spiral. It looks like a corkscrew. We are racing around the center of the galaxy at 230 kilometers per second. The galaxy, in turn, is racing toward the Great Attractor. And behind the attractor, perhaps there is an even more colossal structure, Shapley, hidden behind the dust of our own galaxy center. We just cannot see exactly where we are falling. We sit inside a giant bubble carved out by ancient supernovae, called the local bubble. And right now, even in total stillness, we are moving through the expanses of space, spiraling into the unknown. Chapter 5. Architects of Darkness. But everything we see, stars, gas, dust, is only a tiny fraction. Foam on the surface of a coffee cup. 85% of all matter in the universe is invisible. We call it dark matter. This substance emits no light, absorbs no light, but its gravity gives its presence away with a neon sign. Galaxies spin so fast that centrifugal force should have torn them apart long ago. But something holds them together. A vast, invisible halo. It is like a glass jar holding swirling firefly stars. Without dark matter, there would be no galaxies, no planets, no you. And the most amazing thing, right now, it is passing through you. As you lie here, listening to this voice, trillions of WIMPs, hypothetical dark matter particles, are piercing your body every second. They do not collide with your atoms. They cause no harm. They simply pass through the fabric of existence, like ghosts. We are a sieve, open to the invisible cosmos. But that is not all the gravity there is. There is something even stronger. Moving along the threads of the web, matter falls into chasms, black holes. These are not just cosmic vacuum cleaners. These are regions where the fabric of space-time collapses into a funnel. To leave Earth, you need a speed of 11 kilometers per second. To leave a black hole, you need a speed faster than light, which is impossible. So light is trapped. Time slows down there. If you fell in, you would see the future of the universe compressed into a single instant before being torn apart into atoms. Some black holes sleep in the centers of galaxies, gaining mass. Others are rogues. They were kicked out of their native systems by a gravitational recoil, and now they hurtle through the void. Invisible killers that can only be noticed by how the light of distant stars warps as the hole passes in front of them. Chapter 6. When light plays hide and seek with us. A huge mass warps not only matter, but also rays of light. We call this phenomenon a gravitational lens. A cluster of galaxies works like a magnifying glass. Thanks to it, we see the light of objects that would otherwise be too dim. Sometimes the lens creates an illusion. We see 2, 3, 4 copies of the same galaxy or quasar. The light bypassed the obstacle from different directions. This is called an Einstein ring, a perfect circle drawn by the geometry of space itself. Light is a time machine. The farther we look, the deeper into the past we peer. The James Webb Space Telescope is now finding galaxies that existed 200 to 300 million years after the Big Bang. They are tiny red specks. Many of them are already dead. They merged into other monsters or simply faded away. But their light is still flying toward us. We are looking at ghosts. However, our galaxy is not eternal either. Right now, Andromeda is flying towards us. The distance of 2.5 million light-years is shrinking. We will collide. But do not panic. The stars are so far apart that they will just pass through the ranks without touching each other. However, the gas clouds will clash, creating a storm of star formation. 2 beautiful spirals will merge into one giant, dead elliptical galaxy. We call this future monster Milkomeda. But by that time, our sun will already be dying. Chapter 7. The chemistry of life and the breath of stars. We often think that space is alien to us, but we are its children in the most literal sense. The carbon that makes up your body was synthesized in the triple alpha process inside dying stars. The calcium in your bones, the iron in your blood, the phosphorus in your DNA, all of it was ejected by supernova. We are literally made of stardust. And the chemistry of life is perhaps not unique. In the gas clouds at the center of the Milky Way, we found alcohol in ethyl formate, the substance that gives raspberries their taste and smell. The center of our galaxy, that churning hell with a black hole, smells like raspberries and rum. The universe is mixing a cocktail of complex organics, just waiting for a suitable planet. Stars are alive in their own way. They breathe. Astrosismology allows us to listen to their pulse. Sound waves running through the plasma of the sun cause it to vibrate like a bell. And every star has its own voice, its own frequency, its own heartbeat rhythm, by which we can learn its age and internal structure. We live inside a symphony that our ears just can't hear. But if a star is too massive, its song breaks off suddenly. The heaviest giants die without fanfare. They simply vanish. We have seen this. There was a star in the sky, and then a moment later, blackness. This is a collapse into a black hole without an explosion, a silent death where even the light fails to cry out. Chapter 8. Time, the great illusion. We are used to the idea that time flows the same everywhere, but it does not. Your head lives in the future relative to your feet. It is just that the difference is negligible. But near a black hole, gravity slows the clock down. If you fell into a black hole at the edge of the event horizon, to an outside observer, you would freeze forever, slowly reddening and disappearing. But for you, the entire eternity of the external universe would fly past in a fraction of a second. Time is a river that can change the speed of its flow. And this river flows through the entire history of the cosmos. We live in the stelliferous era, in the spring of the universe. Stars are being born, shining, warming. But it will not last forever. Chapter 9. Twilight of the Gods. What awaits the universe in the future? We now see that the expansion is accelerating. Dark energy, the mysterious force of emptiness, is pushing galaxies apart faster and faster. At some point, the speed of expansion will exceed all conceivable limits. Distant galaxies will begin to go out for us, crossing the event horizon of our visibility. One by one, they will redden, dim, and disappear. The sky will become empty. Our descendants, if they exist, will not see any other galaxies. They will believe that the universe consists only of the Milky Way. And then the fuel for stars will run out. The gas will end. The last bursts of star formation will fade. The smallest stars, red dwarfs, will burn for trillions of years, but they too will cool down. Only white dwarfs will remain, smoldering embers, and neutron stars. The universe will plunge into darkness. We call this the degenerate era. But time has no mercy. Even atoms are not eternal. If you wait long enough, matter will begin to decay. Protons may be unstable. And after an unimaginable number of years, 10 to the 40th power, even atoms will vanish. Black holes, the last monsters, are not eternal either. Stephen Hawking proved that they evaporate. They emit quantum heat, slowly losing mass. And after googles of years, the last black hole will disappear in a tiny, soundless flash. Heat death will arrive. Eternal, unchanging emptiness. No light, no heat, no motion. Just a sea of rarefied particles. But in this emptiness, perhaps quantum fluctuations will be born again. And perhaps somewhere from this tremor, a new bubble of space-time will be born. A new Big Bang. A new universe, which will know nothing about you, about me, about the Milky Way. And the cycle will begin anew. Chapter 10. A dream on a cosmic summer night. But do not worry about the end of eternity. For you and I are at the very beginning of the story. Right now, in this very moment, we are the way for the universe to know itself. You are stardust that has become aware. You are the eyes through which the cosmos looks at its shining spirals and the mind that tries to solve its own riddles. You are not observing the universe from the outside. You are part of this great, mysterious, pulsating miracle. So just breathe. Let your thoughts slow down, like distant galaxies at the edge of the visible world. Feel the silent music of the spheres resonating through you. Feel the cosmic microwave background gently touching your skin, and just let yourself drift along this river of time. Good night, and may you dream of infinity